Page 33, proportional and non-proportional relationships. Chapter 1, lesson 4. The real world link. Pizza party. Miss Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Complete the table to determine the cost for different numbers of pizzas ordered. So for the cost of one pizza was $8, and they put the cost in the numerator up here. For 2 pizzas, we're just going to add another $8, or the same thing as 8 times 2. For 3 pizzas, it'd be the same thing as 8 times 4. For 4 pizzas, 8 times 5. No, what did I just do here? Yeah. No, what did I do there? Oh, I'm jumping ahead of myself. For 5 pizzas, the same thing as 8 times 5, which is 40. For each number of pizzas, fill in the boxes and write the relationship of the cost and the number of pizzas as a ratio in simplest form. So we have, when it was 16 pizzas, if it was just one pizza, that'd be $8, because I'm simplifying it. For $24 for 3 pizzas, that's the same thing as 8 over 1 as well. For $32, we got 4 pizzas. And if I did 32 divided by 4, I would have 8 over 1. And for $40 and 5 pizzas, it's still 8 over 1. And what do you notice about the simplified ratios? Ratios are the same. Each is 8 over 1 or 8. Ratios are the same. That's not much better. Jeez. Ratios are the same as 8 over 1 or 8. To identify proportional relationships, 2 quantities are proportional if they have a constant ratio or unit rate. For relationships in which a ratio is not constant, the 2 quantities are non-proportional. So that would be like your brother or sister getting more of an allowance than you do, even though maybe you're similar in age and you do the same stuff around the house, that sort of thing. In the pizza example in the previous page, the cost of an order is proportional to the number of pizzas ordered. The cost per order was always 8 over 1, and it kept going, so $8 per pizza. All the ratios above are equivalent ratios because they all have the same value. Andrew earns $18 per hour mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. So first you're going to find the money that he earns for working a different number of hours. So you're going to make a table, it tells you to make a table, then it has it for you. For $18, that's 1 hour. For 2 hours, that's $36. For 3 hours, $54. And then for 4 hours, we have $72 that they're earning. Notice how the unit values are over here on the side as far as the labels go. So that means I don't have to put it in there in the table itself. There it is. For each number of hours worked, write a relationship from the amount he earned and hour as a ratio in simplest form. So in simplest form, that just means that we can't reduce it anymore. We can't reduce it anymore. So the amount earned was 18 for 1 hour, or 18. In 2 hours, it was 36 over 2. 3 hours was 54 over 3. For 4 hours, it was 72 over 4, and they're all equivalent because everything simplifies as being 18. So it's just $18 per hour as a unit rate, but as a ratio, it's just 18. The amount of money he earns is proportional to the number of hours he spends mowing. At Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at a school at this school proportional to the number of teachers? Explain your reasoning. Now, there's a lot of information that they do not give us about this. If they don't tell us how there might be one class with only 10 kids in it, we can just assume that every single class, because they're asking for a general statement about the whole school, if they're not giving us more information, we can assume that we can just say that for every 48 students, there is 2 teachers. And to reduce that, so it's 24 to 1. And is that proportional? Yes, it would be proportional because 48 for 2 teachers is the same thing as 24 per student. So yes, proportional. Is proportional at, how about I word this in my notes? Teacher, yeah. At a ratio 24. Yes, proportional at a ratio of 24, because that simplified is just 24, if I could write today. There we go. Yes, proportional at a rate of 24. All right, good, done, okay. Moving along. Now, those first examples are super, super easy. This one, it starts to introduce some other form of a fee, a charge, a set rate that is already there. Uptown ticket charges $7 per baseball game, per baseball game ticket plus a $3 processing fee. And I'm going to circle that $3 processing fee so I remember how that goes. Is the cost of an order proportional to the number of tickets ordered? Explain. So we have a situation where it's $7 for each ticket. So I'm going to just use X as a variable because we don't know how many tickets we're going to be getting. No matter what, there's going to be a $3 charge. So I'll just do this cost. This is actually what we're doing for 8th grade right now. So the cost, if I were to plug in 1 here, 7 times 1 plus 3, that 1 ticket is going to cost $10, and that's where they get this. For 2 tickets, it's going to be $17. 3 tickets, $24. 4 tickets, $31. So if I have $7 per ticket, $7 per ticket at 4 tickets, but I have to add that $3 processing fee. That's where they're getting this. 28 plus 3 is equal to 30. Is equal to 31, and that's where this comes from. So it's whatever the price is for all the tickets, then you got to add $3 to it. For each number of tickets, write the relationship of the cost and number of tickets as a ratio in simplest form. So they're just taking these numbers here and making it into a ratio by just dividing the numerator by the denominator. So for the first ticket, it's going to cost 10 bucks. That's the ratio. Or sorry, 10. For the second ticket, the ratio is 8.5. For the third ticket, the ratio is 8. For the fourth ticket, the ratio is 7.75. Now that doesn't have a quantity on there because it's cost per ticket. But as a ratio, though, you don't have to have the rate in there. Since the ratios of the 2 quantities are not the same, the cost of an order is not proportional. It is not proportional. If it was proportional, we would have 10 as our ratio for all of these, but it's not 10. It actually reduces the amount. The more tickets you buy, the less of a percentage your fee is. You can use the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? Find the amount of sugar and mix needed for different numbers of batches. Make a table to help you with your solve. Right away, hopefully you guys, when you have your homework, there's only one word problem on the homework, but hopefully right away when you read the word problems, you'll recognize that yes, this will be proportionate because there's no initial fee there. There's nothing that is sitting there already. There's nothing that's going to be added on only once. So cups of sugar, we have 1/2 makes 1 envelope, or we need 1 envelope of mix. For 1 cup of sugar, that's 2 envelopes of mix. 1 1/2 cups of sugar, that's 3, and 2 is 4. So when we did that, and this is from section 4.1.1, when we divided 1/2 by 1, we got the ratio of 0.5. When we have 1 cup of sugar and we're dividing to get the unit rate by 2, we get 0.5 again. When we have 1 1/2 divided by 3, we get 0.5 again. And of course, 2/4 is just 1/2. All the ratios between the two quantities can be simplified to 0.5. The amount of mix used is proportional to the amount of sugar used. So that one is proportional, no matter what the sugar to mix is going to be staying the same. At the beginning of the year, Isabel had $120 in the bank. Each week, she deposits another $20. So right away, we have something that is initial. She had $120 that she put into the bank already. From this point, it's going to be $20 a week. So you should know right away this is not going to be proportional because we're always going to have to add on that $120. So when we add, so we started with 120, and then at the end of week 1, she's added another $20 in there. Make sure that. So it's $140 is her balance. At the end of week 2, she's added another $20, so it's $160. At the end of the 3rd week, she added another $20, so now she's up to $180 after almost a month. Is her balance proportional to the number of weeks of deposits? Use the table below to explain your reasoning. So I'm going to find that that's going to be a rate that's going to be the same. I can't change that at all. So that's one of my rates. 2 over 160, that can be simplified to being 1 over 80, comma. 3 over 180 can be simplified to being 1 over 60. So these are my 3 rates that I just found. There's 1 over 140, 1 over 80, and 1 over 60. And since all the rates are not the same, no, not a common ratio so no, it's not proportionate. No, not a common ratio, not proportionate. Not proportionate, because we had that $120 that was in there at the beginning, so that throws everything off as far as having a proportionate ratio. Anybody need that still up? No. The tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? Explain. Now, the way that they worded that, they're not comparing Martin and Gabriel's portions. They're saying, does Martin read at a proportionate rate, or does Gabriel do that? So what they did was they simplified the 4/10 to 2/5. They simplified the 6/15 to 2/5, and you can see that these ones here are all the same ratio. Therefore, Martin reads at a proportionate rate. So if we wanted to know how many pages he's going to get through after, if he wanted to know how many pages he's going to read after 60 hours, we would know that it's 2/5. And to get to 60, we would do 5 times 12, so he would have read 24 pages by then. in an hour. We're not really getting into this yet. I'm just showing you that's where we're headed. As in not today. Not today. Then we have Gabriel. Gabriel had 3 pages read in 5 minutes. And then for the next 5 minutes, he only read 1 more page than before. And then after 15 minutes, it's been 7 pages. So here is the 3 ratios. We have 3/5, 3/5, 2/5, and 7/15. Those 3 ratios are not the same. Therefore, Gabriel's reading is not proportionate. All right, let's see how we're doing. I would like you to please take a couple of minutes and do number 1. I'm going to pause the recording, so if you're watching this on YouTube, as soon as I get done talking in just a couple of seconds, it's going to pop right back into it. But I want you all to do that right now, please. The Vista Marina rents boats for $25 per hour. In addition to the rental fee, there is a $12 charge for fuel, and that stays the same. So that should be a red flag to let us know whether at the end it's going to be proportional or not. Use a table to determine the number of hours you rent. The boat is proportional to the total cost. So rental time, 1 hour, 2 hours, 3 hours. If you did a different value for your hours, we should still get the same thing when we're done. So I have $25 for an hour, but I still have to pay $12 for the fuel. So for 1 hour, I have $37 cost. Then I have $50 plus 12, 62. $75 plus 12 is $87. So that's what the table should be that you guys got. Let's find out they're proportional. 1/37 does not reduce. 2/62 does. It would be 1/31. 3/87 does. That's 1/29. So I have one ratio, another ratio, another ratio. You should have not proportional. At 3 different rates. So it's not proportional because we found that the rates were not the same. But once again, it's because of that $12 fuel charge. If there wasn't a $12 fuel charge, it would be all the same. Does anybody need me to stick on that page or that view? If you do and you don't have a camera, just do an emote or whatever. Okay. Which situation represents a proportional relationship between the hours worked and the amount earned for Matt and Jane? Explain. So I'm going to find what their ratios are. 12/1 is the same thing as 1. 20/2 is the same thing as 10. 31/3 is the same thing as, I'll just go 10 1/3. Move that over. Okay, how about Jane? 12/1 is equal to 12. 24/2 is also equal to 12. 36/3 is also equal to 12. So since we have the same ratio for all these, 12, 12, 12, 1, oops, that's supposed to be 12. We have 12, 10, and 10 1/3. Wow, nope. So Matt's is not proportional, but Jane's is proportional. Jane's is proportional because it's the same rates. Explain what makes two quantities proportional. Having the same, put in shorter words, or constant ratio or unit rate. Because remember, unit rate is something that has, it's in the simplest form and it has a single unit in the denominator.